settings that we might use in the classroom. But when I say traditional learning, I truly mean the traditional method, the process by which the delivery of course information takes place during the teacher-centered class meeting. So this is where, like I'm doing right now, the teacher is on the stage and the students are listening to the teacher-centered. Students spend their time outside of the classroom, further developing and deepening their understanding of the course material, primarily through homework, practice and homework. And so it's again, the traditional way is, when I first went to grad school and I started teaching, I'm a musician, so I love being on a stage. So for me, this is like, yeah, I get to be funny and I get to do my thing for an hour and then, let the students go and they can just deal with what they need to deal with. Next day, I get to be funny. It's like it's an act sometimes. It's a performance. But over the years, I learned my lessons that you can't teach by being funny, this is sort of where I led my idea. So, just with a simple example, I'm using completing the square just because it's a quick one. Just to kind of get a sense of how a traditional lesson might be set up. The topic is, let's say we start with monic quadratics, so the quadratic term coefficient is 1. Monic quadratic equations, we want to complete the square to, let's say, solve a quadratic equation. In terms of learning objectives, if you're very formal about your lesson planning, you might actually create templates like this. And there are times when I'm teaching a new course where I might have a blank template where I say, what are my learning objectives for this lesson? And I sort of write them down so I know where I'm headed. So that's the way this is phrased. So learning objectives for this idea, students will visualize the geometry behind the process of completing the square. It's called completing the square, not just because you're trying to create a square, second power. You're actually trying to literally, geometrically create a square. I mean, that's again, the underlying idea. So for students to understand that, I think that's a valuable thing. Students will conclude that to complete the square, they must do something, right? So they add to both sides of the equation the square of half the linear coefficient, which magically, although it won't be magic once they learn it, gives you that completed square. And then finally, students will solve quadratic equations by completing the square as practice. So that would be sort of the focus. We have the topic, we have the objectives, and then in terms of the actual teaching aspect of it, so I'm breaking this down into 3 different subtopics. What happens before the class meeting, what happens during the class meeting, and what happens after the class meeting. So three different ideas here. So before the class meeting, and again, this would be a template that I might use, a blank template, to write down some details if I'm trying to plan a lesson. So before the class meeting, okay, what kinds of instructional materials and resources are necessary for students to understand the lecture that will come tomorrow? Well, nothing really. I mean, I'm going to lecture, so I don't really need students to come into the classroom knowing anything other than previous knowledge about algebra and simple things like that. So there was really no preparation. Can you all hear me without the microphone? I'm actually going to turn it a little bit sideways. That's okay. I just keep bumping it.
Or not.
Oh, okay, that's fine. So what do students need to know as I begin my lecture? Well, not really very much, just the basics, and so none. We don't have anything for students to do. So now, during the class meetings, and I want to plan my lecture, right? I want to sort of carve out what I want to say and the steps I need to go through, and then the kinds of examples I want to demonstrate. So what I have here is basically, it's in my own words. I mean, you might have a different take on this, but I have a lecture outline. So what I might do is, let's just consider x squared plus bx plus c equals 0, move the c to the other side, get it out of the way, it becomes negative c, and then proceed to look at this problem geometrically. The x squared is a square of side length x by x. The bx is a b times an x. We have 2 areas now, split the bx in half. sort of proceed that way. Move the half rectangles on the appropriate sides of the initial square, and then you have this little missing piece, right? So we all know how this works. We've all, I'm sure, taught this at some point, but that's the geometry behind it, and that's what I would demonstrate in the classroom. Now, in the lecture outline, I might not have included as much detail as I might want to impart to the students just because of space. I wanted to make sure I fit this on one slide. So there could be other details that maybe you might be thinking, oh, maybe this should be there, maybe I should say this. But that's subjective. And then the second part of the lecture, I'll do some examples, right? So I want to demonstrate to the students how this works. They can see this in practice. And so I get my time to actually do some math in the classroom myself. I stand at the board and I do my magic, demonstrate various kinds of quadratics. The first one, example A, I'll demonstrate with geometry just exactly the way I did my lecture so that they can see it in a specific example. And then I have some other different kinds of problems that generate, I have a negative linear coefficient. What happens if you have a negative coefficient? Do you still take half and square? That kind of thing. What happens when you involve fractions in the process? And then the last one has to do with complex solutions. If you have non-real solutions, you're taking the square root of a negative. So that would be it. If I had time during the lecture, I would have in my pocket some extra examples I might cover. The next lesson will probably be part 2, where we would have non-monic quadratics, what to do with that leading coefficient then. If it's not 1, I might, if I had time, I might sort of preview the next discussion. But regardless, I have my lecture, I have my examples, and then now the students leave the classroom and they are charged with doing some practice, maybe some practice problems that aren't counted, just to do some exercising. And then there's a hand-in homework assignment, just some problems that the students write up, hand in, grade it, get it back with some feedback. And then, okay, my office hour is at 2:30 to 3. If you can make it, if you can't make it to my office hour and you decide to start your homework at 2 o'clock in the morning, like a lot of my students do, I'm not going to be around, right? So if you need help, good luck, you're on your own. So, all right, fine. That's the way it rolls, right? Next day, same thing, right? Anything I need to prepare for students to know coming into the next class, not really, except for this lesson, which we already covered, and so on. Rinse and repeat, rinse and repeat. I know you're saying, right, back to the during the class meeting, you might say, oh, but I don't do all of the examples. I have students work on examples in the class. That's awesome. I do the same thing. I'm a big advocate of in-class work, regardless of flipping. I mean, in any class, even if I'm lecturing, I'll do half lecture, half worksheet, or half student group work. But that's fine. I'm just focused on the true traditional model at this point. Okay, so that's, again, what we're all probably comfortable with and familiar with. Maybe not agreeable to, but it's the way it normally works. So now, let me, by contrast, go over the same process of the flipped learning model. So flipped learning is the process by which the delivery of course information, takes place before the class meeting. It's kind of funny, the last talk, we actually had a merging of traditional and flips. We had the video in the classroom, so it's kind of a clash of, I don't know, I felt very uncomfortable. But students spend their time in a student-centered classroom. The classroom is not teacher-centered, it's student-centered. They work in groups. The teacher is there to provide support, to provide direction, guidance. The adage is, you're the guide on the side, not the sage on the stage. You're sort of in the wings. Students work on what they need, and then you provide just the guidance that gets them through it. You might say, well, how do they know what they're supposed to know? Well, let me just go through first a few details about what flipped learning is before I go through the example again. What flipped learning is, what it is not. Some folks think that flipped learning is something that it isn't, something particular I'll mention. So flipped learning is interactive. It enhances the level of direct interaction between you and your students. Because during the class period, you have the opportunity to talk, depending on how big your class is, to each student individually. In a lecture, you talk to everyone as a group, and if there are varying questions and such, you might have time to get some questions answered. But in the flipped model, you actually have a chance while the students are working to talk to each student individually. So it is interactive, it's constructed, it blends elements of effective active learning techniques because it does include working in groups, working in the classroom on practice problems, getting questions answered. It's engaging. It uses class time for hands-on and group activities. Does anyone flip, by the way? Does anyone actually? Oh, okay, cool, awesome. It uses class time for hands-on and group activities. It's personalized. It allows students to excel at their own pace. There's a pace model for the flipped learning model, where if you construct the lessons appropriately, the more excelling students can proceed more quickly through the material. It is a little bit awkward because in a given class meeting, you might have certain students working on some more advanced material, others working on current material. But if that's your thing, that it works out pretty well. The model I'm basically using here is, and I'll give you the reference at the end, is a book by Bergman and Sams, Jonathan Bergman and Aaron Sams. They were both chemistry teachers in Colorado, and they, I don't know, to me it's the handbook. It's the handbook for flipped learning. Again, I'll give the reference at the end. It details how they actually constructed these ideas, and they use the self-guided model in which students would just proceed on their own. A lot of their tests and quizzes were online as multiple choice. So they had computers in the classroom where students can go take a quiz, right? Get their score. If they passed it, they can move on to the next, and it sort of worked that way. I think a lot of us, if we don't have computer access in the classroom, that might not be a doable thing. But it does allow students to sort of personalize their education. And it's archived. So the results, it results in a collection of materials that can be used for review or remediation. So if a student didn't quite understand something, they could watch a video again and again and again, where they can't hear your lecture again and again and again, necessarily. So that's what flipped learning is. A lot of positive things come out of this process. What it is not, and this is some of the negative connotations that come with the terminology. I'm not sure about today, but I know 7-8 years ago when I started looking into this, and I would mention flipped learning to certain people, they would, that's just, students are just watching videos, that's all. Well, it's not really that. It's not just incorporating technology into the learning process. That is part of it, but it's not replacing. It's equivalent. It's not equivalent to taking an online course where there is no physical interaction, because you do have the interaction full-time in the classroom with each student individually if you so desire. So it's not like an online course. When we first started our calculus project at Alfred, some of the student evaluations said, "Oh, I'm not paying for an online course. Why do I need to?" You'll see how the project works in a second, but students think it's an online course if they're watching a video, right? But it's not, because in the classroom you have the time to spend. It's not passively learning by staring at a computer screen. It's not students working silently and in isolation, as you might see in a traditional model where students are working on homework in their own home, alone, sadly. And it's not replacing teachers with videos, which was, I think, initially one of the fears, that why do we need teachers anymore if we have videos that could help teach students? So, the primary role of the student, and this is what students need to buy into. This is really, why I'm more interested in targeting high schools and prior, just because by the time we see students in college, we hope they have some experience with this kind of model. And we do see a lot of students coming in with experience in the flipped classroom. but it needs to be bought into. And if students spend years and years in the traditional model, that's the way they think teaching should be, even though it might not be the most effective method. So the role of the student is to prepare for the class meeting. That's the emphasis. And you'll see, instead of doing homework outside of the classroom, they're preparing for the next class. So it is sort of an equal trade-off. They're not doing extra work to prepare for class. They're just not having to do that extra homework to prepare or to sort of relive the previous class meeting. So they must make use of the quality time in the classroom, which means phones are out of the question. We ban them from even being on in the classroom, because if students are sitting there without someone talking at them and they're asked to work on practice problems, a lot of times the first thing we do is they grab their phone, right? Oh, who's texting me now? So this distraction could also be an issue if you sort of let students. How many have their phones out right now? Yeah. See, I mean, it's like it's in my pocket, and I just want it in my hand. It's like I need to have it in my hand in case it vibrates. I need to know who needs me. That's the age we live in. Students play an active role in their learning. I mean, imagine that. They play an active role in their learning. They're not just pawns. They march into the classroom, get the information, and march out. And again, I'm being very, I'm exaggerating, right? I know a lot of you don't treat students that way, but that's sort of the worst case scenario. Your primary role, okay, so the primary role of the teacher is to facilitate learning in the classroom that encourages interaction, promotes active learning, provides personalized attention. So you are not lecturing for an hour. You are actually helping, guiding, assisting, directing. Throw in a joke every now and then to break the tension. But your role is to facilitate, not to deliver. And one of my favorite quotes from this book is that you can reach every student in every class every day. Every student in every class every day. One thing I didn't mention, we have all kinds of data because our project was a grant, so we needed to have data. We collected data on final exam scores and overall grades and midterm grades and student evaluations and questionnaires. One thing that was really apparent is that with this process of flipped learning, we were able to reduce standard deviations. And if you look at your test, you might see a standard deviation on the test scores of maybe 20 points or more. Sometimes, at least at the college level, we see that a lot because we get so many students from various locales, but we see standard deviations above 20 points. And this project, this flipped project, because we have the ability to bring everyone closer together on the same level or a similar level, the standard deviation shrunk down to nearly 10. I mean, it was astounding. It wasn't just the scores were better. It was the standard deviations were much smaller, which sometimes is a better thing. I don't know. If you write a test that's too difficult and the average is not so good, oh well. But if the standard deviation is just outrageous, then sometimes that's a more important piece of data. Okay, so let's now go through the same process of learning how to complete the square. So this is the flipped lesson plan example. So lesson topic, learning objectives, identical to what they were before. Right, so I won't go over that again, same thing. But now the preparation is different. So this template would be filled out in a different way. Again, I have before class meeting, during class meeting, after class meeting, but now before the class meeting, what instructional methods, resources are necessary for students to familiarize themselves with the new content of the chosen lesson prior to the class meeting. Now, by the way, this is not students teaching themselves. This is students being exposed and absorbing some information, okay? And one thing I clearly say on my syllabus, and I say it almost every day in my classes, you do not need to understand everything all the time. if you're trying to absorb something outside of the classroom and you have a question, bring your question to the classroom, right? Don't panic. It's not the point. But it's to familiarize students with the new content so that in the classroom they can be productive. So you can actually, so this presentation will be available. You can actually click on these links. These are actual YouTube videos. I just looked them up just as a reference. This first video is 2 minutes, 19 seconds, and it's basically a nice graphical demonstration of completing the square geometrically. So it's what I would have done in the classroom on the chalkboard, maybe taken me 3-4 times longer, because this is an actual animation, right? 2 minutes to watch that. Oh, I get it, complete the square. Yeah, you just complete the square. And then the next video is, I think it's a half-hour video, but half of the video is the mnemonic variety. So I say, okay, watch up to 15:32. So it's 15 minutes. Examples, right? So watch some examples, see someone work out some problems. It's not me, so what? Sometimes students don't want to listen to me for an hour. It's someone else, right? But whatever. It's just a few examples to kind of get you thinking about how this works. Some of the advice I give, and in fact in calculus, we require students take notes, and then we check the notes just to make sure that students are still being interactive with the videos. Just because you play a video doesn't mean you're paying attention, doesn't mean you're absorbing anything. So take some notes as if you were sitting in the classroom, right? Pretend you're in the class. What would you do? You take some notes. You would write down the examples just to practice writing. One thing that you could do with a video is you can pause the video. So, oh, here's my example. Pause the video, work it out, get an answer, and then watch the rest, see if you get the answer. Sort of practice that way. It's being very diligent about the learning process. And again, number 3, do not worry about complete understanding. If there's something that didn't make sense, if you were confused, write the question down, write it down. If it's early enough, send an email, right? I check email all the time until I roll into bed, but some of us might not. So write the question down, bring it to the next class meeting, ask the question, make sure you get it straightened out. You will practice during the next class meeting, so even if you don't understand all of the examples, you'll still have the opportunity. So that's basically the preparation. And you might say, well, how could students do all that and finish all the homework from the night before at the same time? Well, again, if this is done before the class meeting, and the class meeting, which we'll do next, is used for the practice and the homework, then after the class meeting, there is no homework, technically. You don't need to assign homework. It's all done in the classroom. Everything is sort of backed up a step. Okay? The good news is that you are there when students are practicing and working. That's the positive part of it. So now during the class meeting, now that the lesson has been delivered, okay, they have the information, they didn't get it, watch the videos again, whatever, you saw the videos, 15 minutes, 2 minutes, that's a very short period of time. How might you use class time strategically? Now what I do, I don't just let students walk in and start working. I sort of give a preview or a review on what we're actually working on that day. So I might do a quick review lecture of the videos, right? Say, okay, well, this x squared plus 10x plus 21 equals 0, which, by the way, was my first example from the old model. I'll demonstrate it quickly with geometry. This is the way it works. Okay, guys, you're going to work on your own now, or in groups, or with worksheets. I like group work because students can talk. I think, as you know, mathematics is a language. Talking is a good thing. And then give them a good number of practice problems, from simple to difficult. Right? If they finish the practice problems and notice the 3 problems ABC are the ones that I would have done in the classroom, let the students do them. Let the students work through them, struggle through them. They have questions that they could ask you because you were there. And then if they finish those, additional practice. This was the practice I would have assigned the night after the class meeting in the traditional model. Additional practice. If they don't finish those 3 problems, fine. At least they got some practice. They can do some practice problems later. what I do, as I said, I require note check. I require note taking, so I'll just do a quick note check and then field any questions. We have the luxury of having TAs in our classrooms for calculus and lower level math classes. So we have some support and help. Of course, our classes tend to be sometimes 45 students. So for one person, to kind of handle all that, it gets a little troublesome. But if students play along, if students go through the process, it's very uncommon to see students in your office. I rarely see students during office hours because every question is answered during class. What could be better? I get to work on the next lesson during my office hours. And so then after the class meeting, what do students do after the class? Well, I don't know, whatever they want, really, except they need to prepare for the next class. Okay, so it's, again, rinse and repeat, but now it's a different kind of take on it. So I would say something like, if necessary, complete the problem set from class. If you didn't finish, just do, just finish what you need, finish what you think is good. You can always ask me questions the next day, or come to my office, we can work on it together. Students will already know how to do these things. It's not like they'll walk into your office and I have no idea what I'm doing. They'll walk in and say, oh, I was able to do these problems, but now I can't do this one. At least they're on a higher level of learning when they walk into your office. So again, office hours, 2:30 to 3. The students know they need to prepare later that night, so they might come in and say, oh, I need to just refresh what we did today. Okay, so that's that. And just to give you a context, by the way, this calculus initiative, it's a full-blown flipped class. And what I mean by that is except for the first 2 class meetings, every lesson is flipped. It's a full-blown. So what I recommend, if you so desire to try this, to try flipping a class, and if you haven't, I really suggest you try it. For some of us, it could be a moving experience, honestly. It was for me. You might want to try 1 or 2 lessons. You don't need to flip every lesson, the entire quarter, the entire year. Try it once. Just say, okay, here's a complicated concept in my math class. I'd rather be able to work with students together one-on-one, have them work in groups. Maybe there's a way I could deliver the information or the basic information before the class meeting and then have the students in class to practice and work. And it's not hard to figure out a good example of that from your own classes. The hard part is, to kind of sort it out. I think it might be a little uncomfortable at first, but once you get the hang of it, it's really a glorious thing. I don't know, I just find it so fulfilling to see the students actually progressing more quickly. So try it with 1 lesson and everything should fall into place. I am available, by the way, for advice. I will provide, again, some resources and such. I'm not saying I'm an expert, but I've been doing this long enough. So this is the calculus initiative. Just some details about it. So if you want to look it up on the NSF website, the grant number is there. It was a 3-year grant. I applied for it in 2011, and then it took the NSF like a year to approve it. So a lot of it was sort of waiting. The first grant I ever wrote, and it was accepted. So I was walking around 6 inches taller for a few years. But anyway, yeah, I don't know if you've ever tried to apply for a grant. Sometimes it's not easy. Anyway, the way I set it up was as follows. So because this is calculus, has anyone taught calculus? Okay, a few of you. Again, this is a college level example, but it gives you sort of the scheme. Ever since grad school, so ever since I taught calculus for the first time, It wasn't when I learned calculus, because I was just following along, right? When I first taught it, trying to prepare lectures after lectures after lectures, scratching my head going, wait a minute, this is kind of odd, right? Students need to know all there is to know about algebra and trigonometry and geometry, pre-calculus, before they even start calculus. So that's a problem, first of all. Students come into the college classroom on day one as first-year students with a variety of different backgrounds. Some students have very outstanding SAT scores in math, some don't. So you have this playing field of varying levels of students. So the question, I guess the problem was, how do we ensure that we can get students to the same level to at least start to talk about calculus concepts? So that was one issue that I needed to address. The other was basically, if you know how calculus is traditionally taught, it's basically, let's do some pre-calc review, let's talk about limits, let's talk about continuity, let's talk about now derivatives. Okay, so now when you're working on the derivative, slope of a tangent line, you need to know all about those other functions. You already need to know about lines and quadratics and exponentials and trig functions to be able to do things with derivatives. So then you learn the derivative, and then you're thrown a bunch of different examples with all kinds of different functions. So not only are you trying to remember everything there is to know about these functions, but also what the derivative is and how to compute it. So I thought, well, I've learned in my career, repeating myself sometimes has more effect than talking louder. It's like, could you repeat that? Yeah, I'll repeat it, and I say it louder. But sometimes it's you're repeating yourself is a good thing. So I'm like, okay, well, how could we get this repetition thing into the curriculum? So those two things kind of led me to write my own calc book. All right, so this is non-traditional. If you're interested, I could send you a copy. It's free if you want to use it. I mean, but anyway, it's a new curriculum. It is not eliminating any of the topics that a traditional calculus class would offer. It's a rearrangement. So basically what happens is chapter 1 is a chapter on constant and linear functions. Okay, so you might say, well, all right, that sounds simple. But yeah, because constant functions, can you find the slope of a constant function? Sure, that's the derivative, by the way. Can you find the slope of a linear function? Sure, that's the slope. That's redundant. That's the derivative, by the way. So now, with just lines, students know what a derivative is. Can you talk about integration? Sure. What is the definite integral under a constant? Just a rectangle. Can you compute it? Sure. What's the integral then? Well, it's just the area. Can you do the area under a line, trapezoid, right? So they know what derivatives and integrals are in chapter 1 with those simple functions. Chapter 2, I won't go through each chapter, but chapter 2 is quadratics and cubics. Okay, so now you know the problem with quadratics is they're curvy, right? How are you going to find the slope of a curve? Well, you set a board down on it, and you try to find the slope of the board. And then you have to incorporate the limiting process gently, and then go along that way. But they already know the words derivative, integral. They know what they are, they know what they mean, they know what they represent. And then it just progresses through function type. So in chapter 3, we do piecewise functions. Chapter 4, exponential functions, trig function, rational function. Every chapter is a different function. And so in that context, we're able to develop the formulas, the rules for differentiation, rather than saying, hey guys, here's a sheet of 1,000 differentiation formulas because you already know all these functions. We also get to review the pre-calc. The first section of each chapter is basically a pre-calc review. So it's a just-in-time kind of thing. So rather than having 2 weeks at the beginning of the semester reviewing pre-calc and crossing our fingers hoping the students remember that throughout, before each chapter we have a review of those function types, and then they sort of keep that fresh in their minds as we proceed through the process. So that's it. It's all there. All that you would ever want to know about calculus is there, except it's just rearranged. So on top of that, how much time do I
lot.
A lot, awesome. Okay.
20 minutes.
So the next step, once this was broken down into chapters and then lessons, subsections, which we call lessons, we needed a way to deliver that information. So it was basically creating lesson and example videos. So the videos that we have are mine. They're me. If you're just starting to flip a classroom, if you want to do a lesson, feel free to. There's all kinds of software out there. You can do screen capture. You can do. I've used my iPad, set it up on my desk if I needed to sort of do a quick example for students and send it off to them. Just set up your iPad and record yourself at a board, or I have a tripod that has an overhead view. I can just write down as if students are sitting next to me. A lot of ways to record yourself. If you're not comfortable with that, YouTube, thousands and thousands and thousands of possibilities. Sometimes you spend more time trying to find the best possible video than anything. Oh, there's a good one. Oh, maybe I can find a better one. It sort of takes a lot of time to sort it out. It's all available, right? We're in the age now where it's all available. So you can find lesson videos pretty easily. What we did is we had two separate sets of videos. So one was me doing a quick lecture at a whiteboard. I have a screenshot, I'll show you in a second. And then the next video with the examples, we have them separated out so that students don't need to sort through a full-length video to try to find examples. So they're all on a separate video. These videos average, the lesson videos average 11 minutes, and the example videos average 17 minutes. So it's like a half-hour work, right, for students to watch. So that's the way we deliver the information. One thing we struggled with is how to make sure students actually got something from the videos. So we use WebWork. It's out of the University of Rochester. Maybe you've heard of it. It's basically just a short 2-3 question online quiz where students go in and the problems were written by us. They model the examples that were done in the videos. So it's basically a mirroring kind of thing. Students watch the example. Oh, I understand that. Take some notes on it. Now I'm going to try my own. Right? Something very similar. So that students can say, yeah, I get it, or I think I get it. Just something basic. So that's a check. That's a way for students to check themselves. It's also a way for us to, we count this as part of their grade. It's a way for us to make sure that students actually do something. So online quizzes. And by the way, so the prep time before the class, you figure on average 11-minute video, 17-minute video, 28 minutes, the online quiz about 5 minutes. This is basically 35 minutes of work. Then students come to class. In-class activities in the textbook, we have actual worksheets in the textbook itself. Problems with blanks, students actually write in the book. They complete the activities with us, the TAs in the classroom, get their questions answered. They're provided with answers, not solutions, answers. So they can check their answers as they go. They don't need to wonder what the answer is. They don't need to ask the teacher what the answer is. They can check their answers. If they're good, they move on. Question?
The online quiz is before they come and receive class instruction.
Yes.
Do you check that it's done before they come in?
It is checked for grade. That's the one thing. So quizzes are worth 5% of their total grade, minimal, but it's still an incentive. And it is checked to make sure it's completed. Yes. If it's not, what we do is we hand the students a set of headphones, send them down to the computer lab, and say, here, embarrass yourself now, because you have to walk out on your friends. Take the quiz, come back. There are ways. You do that one time, no one else will do it again. Okay.
Thank you.
Yeah. There's a level of trust both ways. You have to trust that the students buy into it. They have to trust that you know what you're doing. So it works both ways. Once you have a student leave the room because they didn't do something, the other students will follow suit. They'll make sure they have their work done. Okay, and then what we tried initially was we had a separate online homework assignment as extra support. It didn't work out very well just because of the extra time that students needed. So we learned our lessons, so what we do now is we have this web work homework assignment, but we use it a lot of times either as bonus, so we'll add 2-3 points to their test grade. So that's an incentive. You add bonus points, like, yeah, I'll take that. They'll work on extra homework, extra practice, right? Or we just leave it as, do it on your own. So it depends on the situation. Sometimes, as you know, you might have a class of students that are willing to do extra practice, sometimes you don't, and you need to give incentives to the students to actually do something that benefits themselves. So that's the process, and then this is all based on a website, which I will give you the link to. It's an open access website. All of this material is open. There is no login except for web work, which is password protected. But all of the information is free. So I will give you the website at the end. And then one thing that came out of this project is the use of this off-site. In Alfred, so we're in the Alfred Allman School District, which is about 6 miles down the road. So we had the university had this plan where we would allow students, high school students, to come to our campus for a nominal fee and take junior and senior level classes, $100 flat, not by credit. That's $100 flat. As long as you can get here, as long as you can get back and finish your high school schedule, right? You can take calculus and chemistry and physics and whatever the heck you want. The problem with that is sometimes our enrollments fluctuate, but our faculty numbers don't. So sometimes we were to the point where our calc classes, our sections were filled, and the high school students wouldn't be able to come and take our classes. So okay, well then they'll take AP, right? But a lot of students want that experience. They want to sit in the college classroom, to know what it feels like, to actually work alongside college students. So the idea here was, okay, well, maybe there's a way we can take this package and export it, right? Say, okay, we can send it to the high schools, right? I'll talk about that very shortly. So we use this offsite. So just to kind of summarize how this works, just in case you didn't get it. So for homework on Monday, let's say, for homework on Monday. So there's the screenshot of the video of me at the whiteboard, writing the details down, talking through it. Again, average video length, minimal. So step one, watch the lesson video, follow along and take notes. By the way, the transcript is in the textbook. So if they have problems with internet connection, right, they're not missing anything, they can just read, it's one page, read the page of the textbook. Step two, watch the examples video. So this is shot overhead, it's just, that's my hand, right? So I'm just literally writing out, discussing the examples, and students copy it as if they were sitting in the classroom. Record any questions, take notes. There's space in the textbook to do this, by the way. So the examples are blanked, and then they just copy it down. Complete the web work quiz, and it closes, so they don't have access to it unless you provide them access. It closes before the class meeting. They're locked out. If they desire, if they missed it, you can provide that luxury with penalty as you see fit. On Tuesday in class, come to class prepared to work, talk, and ask and answer questions. Okay, and so students very quickly understand that they need to come in because they'll be grilled, right? You can walk around and just ask random questions of students, and they'll be ready because they know what they need to prepare for. Some ideas, the instructor may summarize the lesson. I typically do that, and so on and so on. Students work in groups. And then by Wednesday night, they might have this web work assignment to use as practice or bonus points, depending on the instructor preference. We rarely ever have it as a graded aspect now, just because of the time constraints. These are college students, nonetheless. They have a lot of other things to do. So here's what I was referring to as far as the offsite. So we have this thing called the AUCI High School Program. So currently, it's open to high school juniors and seniors. This is not a plug, by the way. I'm not here to sell this. I'm here to talk about flipped learning. But I thought this might be interesting to some of you. We created this thing through GST BOCES, which covers the counties that you see listed. We're about to include Mount Morris, which is Livingston County, which is outside of GST BOCES, which is not going to be an issue. But currently, these are the counties that we deal with. Because everything is a package, it's free except for the web work stuff, which we coordinate with the teachers. We send it out, in a zip file, send it out to a teacher on the high school campus who serves as a course adjunct. They don't get paid by us. It's part of their typical load. And this is, of course, for high schools that can have a calculus teacher on site. So the high school teacher serves as the facilitator. Basically, students still watch the same videos, they take the quiz, we provide access to the web work. But in the classroom, it's not me, it's not my colleague, it's the teacher, the high school teacher in the classroom, doing the same thing that I would do. The student, prepares the same way. The testing is done with the high school teacher actually administering tests, grading the tests. Again, it's basically we ship it out. We don't do anything except monitor. We give templates of tests if they want to use templates. They could write their own tests based on the problems that students have seen. Students earn 4 university credits in first semester calculus if they pass the course. Alfred Almond actually replaced their AP calculus with our course just because it was so successful. I know Corning has another similar type of thing, which I think costs more money than ours. I don't know. It's all about budgets, right? But students don't need to leave their campus. The high school teacher can create the schedule, so that the students can be accommodated. It doesn't need to be only the students who can make it to our campus at 8 in the morning, right? Everyone else gets shut out.